The 7.1 Go is a nice review of our solving systems of equations. This is what we were doing back in chapter 5. So in this, the Go here, you're going to either be using substitution or elimination method. Now, it also says you could do it by graphing or matrices, but I don't want to do any graphing right now, and we haven't done matrices yet, so probably don't want to do those. Okay, the substitution and elimination are the quick ones. So to do substitution, you want a variable isolated. So if you see a problem where you have an x equals or a y equals by itself, that's probably a good time to use substitution. Something like with number 9. Where on number 9, we have an x equals by itself, we can just replace the x down the other equation with that 11 plus y. That's the substitution method. When you have an x equals or y equals by itself, variable isolated, you can replace that variable in the other equation. Whereas number 10 doesn't have anything isolated. Now I could get x by itself pretty easily, move the 3y, but this is another time where I'd probably want to just use elimination. If I look at it right now, nothing's going to cancel, but it'd be pretty easy to either multiply by 4 on the bottom or a 3 on the bottom and make opposites. If you make opposites, then you can go and multiply one or two of the equations, get your opposites, and then just add and cancel. So I'm going to walk through examples numbers 9 and 10. These show both methods. For number 9 with substitution, I want to get that single variable. I want to replace the two variables and get down to a one variable equation. If I take that 11 plus y, which is equal to x, and substitute it into the other equation where x is, this gives me a single variable equation. It's just y's. I can distribute, the 2 times 11 is 22, 2 times y is 2y. Combine my like terms, the 2y plus the 1y is 3y, and I can now solve this for y. Subtract the 22, divide by 3, and so on. Once I know what y is, I haven't finished the problem though. I need to plug that value back in, and I also need to solve for x. Remember, when you're solving a system, you're finding the point of intersection. A point is an x value and a y value. I need a coordinate. So I can plug this back in. Top equation's a really good one to use because I'm solving for x. I want x by itself. And just substituting that -1 and see what we get. X is 10. But again, we're looking for a point of intersection, so we're not done yet. We still need to write it as a coordinate or a point. The coordinate or the point should be 10, -1. And we'll do the same things. Something like number 12, where we have a y by itself, or 13, where there's a y by itself. Those are a good one for substitution. If we don't have that variable by itself and we don't want to isolate it, then we use elimination. Now, unfortunately with number 10, right now nothing's going to cancel. A -4x and a +1x, they're not going to eliminate. A 9y and a -3y, again, they don't eliminate. They're different signs, but they're not opposites. So we could either multiply the bottom equation by 4, make the x's cancel, or we can multiply the bottom equation by 3 and make the y's cancel. Pick one. Okay. I'm going to go with 4, so I'm going to make my x's cancel. If I multiply both sides of the bottom equation by 4, top equation I don't need to change, but when I multiply the bottom equation, that's going to give me, instead of the x minus 3y on the left, it's going to become 4x minus 12y on the left. And then on the right side, -6 times 4 is -24. Now I can eliminate. Now if I add these together, the x's cancel, and the 9y minus 12y is going to be -3y. The 9 minus the 24 is -15, and now it's a much easier equation to solve. Just divide both sides by -3, and we get y equals 5. We can substitute it back in. I'll take the bottom equation because it's just x, makes it a little bit easier to solve. I won't have to divide. Substitute in my y, -3 times 5 is -15. Add 15 to both sides, and I get x equals 9. There's my point of intersection. Okay, you're going to do the same thing here for the ones that do not have a variable isolated, something like number 11. Good luck.